So I'm Frank. I'll be talking about Frontin like a backer. For the people that don't know me, Sean gave me a nice introduction already. I'm the guy behind Flysystem. Ironically, you said like Flysystem was the stuff that backed Laravel Cloud, like the file storage there. I actually was at a meetup not too long ago, and I was talking to some people, and I was talking about the project I was working on, and I said, well, Flysystem does this and that. The people that use it here know what it does. And I was explaining the concept, and it's like, the guy responded back to me, is like, that Flysystem, what you're talking about, did you just basically recreate Laravel's cloud storage? So, anyway, but now that I've got you all here, because the success of Flysystem has a lot to do with the success of Laravel as a framework. Like, the amount of downloads over the last couple of months, it's just grown immensely. Like, you could see the first year and a half, like, you think it's flatlining there, but like, I installed it in my projects, like, every once in a while, like, do an extra composer update to get an extra number in there. Super silly. But then, in Laravel 5, well, before Laravel 5, it started to go up, and it kind of started to gain some popularity. But you can see, like, the spike there, that's where Laravel 5 was released. And, like, this says something about the release and adoption of Laravel 5 as is. But, like, the line would be a lot more flat. So, seriously, thank you guys for embracing it, even in Laravel 4 and now in Laravel 5. Thank you. That means the world. So, but I'm not here to talk about my PHP stuff now. I'm actually going to talk about friendship. And when you look at friendships, we have our good friends, we have our distant friends we see every once in a while, and then there's this other kind of friend. So, we all know this guy, right? Or girl or whatever, this person. You've got one guy or girl in the group, and it's semi-awkward, or like you have the handshakes that go like this, and it just doesn't work. But still, you consider them your friend. And for me, that friend is JavaScript. So, thank you. Over the years, I've had my arguments with JavaScript. We've had our fights. I've broken up with JavaScript several times over. But JavaScript just keeps coming back to me. And over the last couple of, well, years, I've figured out a way how to deal with it. So it kind of transitioned into something like less like this and more like this. Like, it's a weird friendship, but it works. So that's kind of amazing, I think. Like, I was Googling for weird friendships, and this thing popped up, and I was like, what's going on, right? So, but you know, like, if you have one of those friends and you take them along to parties, but you feel kind of weird introducing them to your friends, you know, there's always this awkward tension. And so I went to my friends, and I looked at what they had to say about it. So one of my friends is Rafael Domes. For you who don't know who this is, that's the guy who built the community here in Amsterdam. He's done it before in Brazil. He's doing a stellar job at that. But I asked him, like, what do you feel when you're writing JavaScript? And he came back with this, and this is probably as real as it gets. He said, writing JS is like eating a stroopwafel. And if you don't know what a stroopwafel is, it's the gorgeous thing at the back. It's super delicious. If you haven't had one before, don't leave Amsterdam without eating at least 50. Go with 50, just to be sure. He said, it's like eating a stroopwafel, only there is no waffle, and the caramel is hot oil. It's like, that's the most painful experience, right? And as so happens, like, that's just one guy's opinion, right? Could be just him, but I thought maybe he's not alone in this, and I kind of figured that he wasn't going to be alone with it in this. So I asked more people, and this is what they came back with. It's like, yeah, I really don't want to do this, but there's no other option than using JavaScript. JavaScript is just a means to an end. And there are other friends of me who own companies, and they hate JavaScript so much, they'd rather employ somebody and actually have to get him a paycheck every month, which, like, from Ben's talk, you know, is like tremendous effort to, like, it really puts some constraints on you in some ways. They'll rather hire somebody than have to deal with that. But if we all hate it, like, I'm just going to say, you all hate JavaScript. Let's take it from there. If we hate something, why do we do it? Why do we keep using that same tool? As it turns out, like, a lot of things are really beneficial. It adds quite concrete value. If you have a web page and it's just static, there's really no interaction, and the feedback loops are kind of slow. Everything has to hit the server first, and then there's interaction there. Like, you have a different page, which is kind of the transition then. But JavaScript allows you to do a much better user interaction than that. You get faster responses, everything just feels more snappy, and if you're in, like, the e-commerce sphere, you know that those kind of metrics, they really matter for the business. But there's also this other part. When I do JavaScript, or no, rather when I do backend stuff, I do all this smart and complex stuff at the back, but if I then go home and visit my mother, and I need to explain to her what this smart stuff that I'm doing actually is, it's kind of hard. One, she doesn't know code, and two, she doesn't know the business. So, but then again, if I do JavaScript, there's all this stuff happening on the screen, and it's like intuitive, and she knows what's going on. Even if it's like jQuery animate, my mother thinks I'm a rocket scientist. So that's a straight up win. So yes, this talk is about JavaScript. Let's just sink in for a minute. Just to be clear, this is not a talk about loving JavaScript. While I just hated on JavaScript by proxy through my friends, it's not about hating JavaScript either. But as we all know, it's a language that we have to deal with. So this talk is about dealing with JavaScript. So let's take a step back and reflect for a little. Let's look at why there is so much hate when we actually deal with JavaScript. So what's really horrible JavaScript? This is what I define to be horrible JavaScript. There are a lot of people who are like the anti-jQuery segment nowadays. But for me, it's not even the part that we have to deal with browser differences, but everything here in a logical flow in some ways is not as structured or as logical as I'd like it to be. Just take this simple example. You have a window. Well, I'm never dealing with a window, it's a browser, right? So anyway, so when the window loads, we expect a lot of things to be there already. When the window loads, there should be a link with that is an external link. And when we click it, we prevent the default behavior. Then we ask the client, well, is this really what you want to do? When that's the case, we remove the click handler, and then we click again. So actually, that concept of when I do this, this happens, there is like this internal mutation going on, re-instigating the same flow, but then bypassing it. So even in this, like, what is it, 7 lines of code, there is like massive logical complexity that, like, if you scale this out, this is not gonna work anymore because this is hidden logic all over. But we like to have our HTML and our JavaScript separate because that's good separations of concerns, right? Well, I would beg to differ. I think this is not separation of concerns. This is segregation of concerns, or just tackling one concern in 2 places. So they're implicitly bound at the hip. It's also error-prone. Let me give you 10 seconds to figure out what the bug here is. If somebody finds it, please raise their hand. Yeah. Okay, I saw 2 hands, 3, maybe a couple more. So we're with 450 people here. We look over code like this daily. We need to be able to do that fast. Actually, what's wrong here is this thing. This is an underscore, and this is a, dash, or what is it called? It's a minus. So, and here, this is easy to spot, right? We've got a script tag, so we've got it in line. But when we actually do JavaScript, these are 2 different views. Like, either I'm viewing my JavaScript or I'm viewing my HTML. Like, how hard do you want to make it yourself to go into these kinds of error? Like, there's implicit bindings between the 2. It can easily cause errors like this. And when we look at it like that, like, we hate the language, but we have to deal with it. What you naturally flow into is like this results-driven approach. I don't want to touch it all that much because I feel like I need to take a shower after I do some JavaScript. So I'll just go in there and get out quick, just enough code to make it work. And then, because it's result-driven, the result is going to be good. It looks good at the front, right? And that's important too. Like, we wrote it, the client's happy, it works, but we also have to maintain this stuff. And then when we look at the back, all of a sudden it's not so pretty anymore. And this is the world that we live in. Like, our happiness will shine through to the work that we do, and we'll make our clients happy. So what you could then say is, JavaScript in that way is just not good enough. But I would argue that not good enough is not the correct term. What you could say instead is that it doesn't supply what we need. The code that I previously shown was like all these statements, basically sequential programming, but then in JavaScript, so you get the added luxury of breaking your brains over callbacks and async stuff. But that mental model doesn't scale as well. So what we could say instead, it doesn't supply what we need. But then, okay, what do we need then? So we need some way of generating elements that are rendered on the screen. So we need some kind of templating stuff. We need some kind of way to interact with APIs that we have from our backend stuff. So XHR requests, like that's the new and fancy term for stuff that we would previously just call AJAX. So we'll have to use that. And data is going to flow between the application that we have in the front end and the application that we have in the back. So we need some kind of data handling. So encapsulation there, we need some kind of models, and we need some kind of lists or fancy arrays. So in JavaScript, that would be some kind of collection facilitation. So of course, the JavaScript world didn't just sit down and do nothing. They came up with solutions. So then there were like our heroes, right? Probably everybody here in the room has worked with 1, 2, or all of these tools, and possibly more, like things like Knockout or whatever. They are here to protect us from evils. But when we look at them, this is an example pulled straight off the Backbone website. And I find this funny because everybody can pretty easily understand what's going on here, right? No real questions. We've got a view, and it's a list item, it's a document row. When we click on the icon, we open it. Well, there's no open handler here, but use your imagination. We have some sort of constructor, which is called initialize because reasons. And then we have a render method. And when I look at views, I think I'm going to be generating stuff. And the irony here is that we've got a render method, and Backbone says, well, good luck, buddy. You're on your own. You have to do all this stuff. Like, you're in charge of the rendering process. So it's only like a harness, but the actual, like the muscles and everything, the bones, it's ironic. It's only a harness, and you have to bring the bones in Backbone. So. Anyway, so you have to do that. Angular, same kind of problems. We have pure HTML here, right? Like, no JavaScript here? Well, I wouldn't say so, because above we have a declaration of what kind of controller this is going to be using. And also we have markup, presentation logic, but more like mapping logic here. And if you think of data and you do a map, it's like an array map. But here you have an Angular-specific DSL for specifying loops, which is basically the same as just having JavaScript in here. This is JavaScript because it doesn't mean anything else. And then there's Ember.JS. And Ember.JS has Handlebars, which is a Mustache kind of thing. And I went back to do research on all of this because I've previously worked with all of them. And I went back, like, what's the essence of a view? So I opened up the documentation, right, because that's what we do. And I looked at the screen height of the page that was explaining views. I took my screen height and the total height of the page, and it was 23 pages of documentation just to explain what a view is. So, yeah, my mother is right then. I should be a rocket scientist to understand this. But they have one thing in common, and that's they say, you don't like JavaScript and HTML. Here's something completely different. It turns out that brings a lot of problems. How many times do you see questions on Stack Overflow basically asking the same concept, like how do I do loops or how do I do whatever in framework X? So it just doesn't work, right? So when I went through this battle myself, I was like, yeah, I'm out. I'm just going to go back to HTML. That's the stuff I'm going to do now. Doing it in all those frameworks, it's hard to debug, it's hard to understand, but most importantly, it's so much different than what I'm used to writing backend applications. And that mostly comes down to what we're used to, right? This is the flow that we're in when we handle requests. We take everything into account. We break it up into small steps. We get an HTTP request. We extract from it what we need. We collect the data. We process that data. Then our application, our domain, or whatever you want to call it, sends back some data, or you have to fetch it separately. It's all the same. Then when we have that data, so like what's important to the business, we ship that as a unit into our templating engine, and the response there, we send that back over HTTP. So what you could say, when you get that response, it's the current application state represented in HTML. What you get back is the truth. And the format of what we get back is really simple, but it has some unique properties to it. First of all, it's declarative. It's not like with event handlers, like remove class here. It's like, that's a mutation, but this is just as is, so it's declarative. Also, you can use it in compositions to create more meaningful structures. So your page has hierarchy, and that hierarchy has value. But once your browser has interpreted it, there's another unique property to it. When you get things back like a checkbox, the initial state would have been that it's checked. But once you receive it, you have the ability to mutate it. You have the ability to change it, which is really a powerful concept. That's how you interact. Like, once you've done all your mutations, you basically send it back to the server, and that's your intent then. But why can't solutions like Ember and Backbone and all be like that? Like, have some of the same traits? And that's why, well, a while back I started doing research and researched a lot of tools that were kind of addressing the same thing. But in the end, I ended up really liking React.js. So I don't know how new React.js is for you. It's relatively new in the entire sphere, but like, if you haven't heard of it before, don't worry. I'll explain it all. What's so unique about React? And this is the simplest thing. You can define a component and define declaratively what it expands into. So we have our Hello World component, which is a React class, which has a render method. And what you return is an H1 with Hello World. And then when you use it, you use a HTML-like declaration of that component. So, like HTML, it's declarative. And I know that some people look at this and like, what the hell, man? There's HTML in my JavaScript? Where's all the separations of concerns? And like, I kind of feel weird about doing this. It kind of feels, yeah, ugly. I've got a very good tip. No, but okay, this is an easy statement to make. But if you look at it more deeply, JSX, and that's what this templating language is called, is just a domain-specific language for HTML and JavaScript. And what's the best syntax to model HTML, which is already a syntax? If somebody has a better way of modeling this than just HTML, I want HTML, how do you model it? Well, maybe HTML. Sounds quite logical to me. So this is how you write it. You write it like this, but this is not actually what the browser runs or what it receives. Before you ship it off, you compile it, which is pretty easy. If you do modern JavaScript stuff, you have Babel.js, which will transpile the flavor of JavaScript that you like to write into something the browser needs to run, because it might not have the newest feature. So what it's actually desugared to is this. So it's almost the same. We just replace the H1 tag with a create element statement. We pass the properties into it, and we pass the body of the element into it. So it's not HTML. It's just a fancy way of writing a function, or a function call in this example. And just like HTML, as I said, it's declarative. I want a modal window here. I put a modal window there. You can pass properties to it. Here you see it's a little bit different than normal HTML because you can actually use JavaScript types here. So if you use the brackets instead of normal quotes, you can put actual like scalar values. I don't know what the name is in JavaScript for that, but For us PHP people, that's how we call it, right? And just like HTML, it's composable. So in our model window, we have a header. And that header has a title, and it's Hello World. And there is a body, and we can go inside there and compose what we want, what we want to see on the screen. And this is a really generic example. But if you look at this in a way that you want to show intent, how difficult is it to understand what the intent of the UI that's going to be rendered on the screen is when you see this? It's pretty clear. It's probably the clearest that you can get. But that's nice. But we're not doing static JavaScript. Like, we're not doing static markup in JavaScript. You want to be able to have that dynamic factor in the equation as well. So you have to think about what is data in the UI. So what is data in the UI? Data in the UI breaks down into two pieces. That's properties and state. Let's go through them one by one. Properties is external input. It is everything the UI needs from the outside world to create the presentation it wants to deliver to the client. So compare that if you are in your controller, and before you send anything to Twig or Blade or whatever, you collect data and you feed that into the system. So properties are that, but then for React. So how does that look? Here, I've created a badge component, which is just a simple thing with an H1 in it. And on the bottom, you see how it's rendered on the, like how you use it. So let's start from the bottom, wrong way out. We have a badge, and we say the name is Kayla. But that expands to this React component. So inside the component, we can see it's actually a div with a class name of badge, and inside there an H1. And there you can see that we use the same notation, like with the curly brackets, to actually get something out of the JavaScript world. So everything you pass as a property, like HTML attributes, it gets hydrated in the props object, so you can use it from that. But it's not just string values or Booleans. Well, it can also be Booleans. Like here, if you want to say, I've got a name badge and I want to say who's awesome and not, because we're super judgmental and we like to do stuff like that, you can use Booleans to do this. And in here, you can see the presentation logic for what the description is. It's just a simple statement, and we output that in the template that we return. But we could even take it a step further, and what we could do is have a collection of badges that we want to render to the screen. So we create a badge list. And this badge list, it requires an array of people. And what you can see here is that because everything is just normal types, we can use the people array, map over that, and use a different component that we defined before to create a collection of those React elements, and use that as the body of the new template output. So this is a really powerful concept. Even inside, we can decorate or facilitate more complexity than just single template rendering would allow you to do. On the other hand, state is everything that's internal. When you look at state, it's easy to think of the example of a checkbox. If you want to rename it, name it toggle, what we basically could do is say, we have a div, and it's either a div with the class toggle completed or toggle, based on the state that the component is in. State is something that the component can supply for itself. So we have a callback during the element lifecycle, which says, get initial state, and I return whatever data I want to have available for myself. But state wouldn't be much of use if it was just static, so we can manipulate that as well. And this is where the line between like how much better I find working with React is compared to the other solutions really comes apparent. If you look at this, we have an onClick handler on the div. So when we click it, the onClick function is called. Internally, we call the setState method, and it just updates the state. But if you look at the declaration of what we want to output, it's still the same. So it's still this declarative way of saying what the UI should look like. Which is, again, super nice, but what about my data? I want to be able to work with my application. So let's look back at the backend flow. If you look at the backends, it's pretty much, we get an HTTP request, we process it, get relevant data, and we respond with a rendered view. But if you look at that in a more abstract way, we could say there is an action which holds the intention, we have our domain, we do business stuff, and then we respond with either JSON, HTML, or XML if you, yeah. For the people who like XML, do that, okay. But how does this map to JavaScript and React? Well, in short, it doesn't. The action, you could say like a click event is an action, so that's your intention. And the response is obviously what React renders to the screen. So the only part we're left to define is everything in the middle. But what we could say is, because we have to interact with external stuff, is that we have to have some kind of store where we get the data in where we store it, and we need some way to interact with services. So stores hold the application state, while you use services to interact with APIs. And if we put this in a diagram, again, from the backend side, we could say it's a linear motion. We've got HTTP, we go through a routing process, which kind of dispatches us, like it dispatches the correct controller code to be executed. Our domain handles stuff, and then a view is rendered. It's like Blade or Twig or whatever. So if you look at JavaScript, we could say we need an action, some sort of dispatcher, and then we need to hold the state, so in some kind of store, and then we output a view. This is actually a pattern that's risen. What's the past tense of rise? Risen? Anyway, that word. Which is called Flux. Flux, though, is merely a pattern. There are many implementations. I've worked with a couple of them. There are a couple that are really good, and they vary from super pragmatic and super easy to understand to full-on functional programming, super abstract implementations of it. But for the purpose of this demonstration, I've chosen one that's easy to understand, one that I've worked with a lot, and that's Alt.js. And what Alt.js supplies is two of the components that you're going to be working with. One is actions, and the other is stores. And if you look at a project, you will see this separation. We've got actions, like a directory with different kind of actions. Then we've got stores and components. Components is where your React components are going to live. So, of course, it's really good to have a solid, real-world example of something you're going to build. So, obviously, we're going to do a to-do application. When you look at a to-do application, you just look at the components that are into play. This is what it looks like. Alt.js is the instance that we're going to instantiate from the alt package, which is going to be our dispatcher. Then below that, we have our actions, which hold the intent. Once we get data back, we need to register that in stores, and then we've got our components which will render it out to the screen. So if you look at this in a flow diagram, we could say when an action triggers, it goes through the dispatcher, the stores get notified of that, update their internal state, and notify the views in order to re-render themselves. And this is actually a loop, so it's not one way and just there, because the UI will actually also allow you to emit some of those events. So let's look at some code then. First of all, we instantiate alt, which is our dispatcher. If this syntax is unfamiliar for you, look at tools like Babel.js. They will allow you to create nicer syntax, like use nicer syntax when you're writing JavaScript. Like we've got import statements, like use statements in our PHP. We've got imports in JavaScript, which basically facilitates the module system there. So we import alt from the alt package. We instantiate alt as a constant, and then we export it, which means we can use it somewhere else. Next important stuff that we want to create is our actions. So once again, if this is unfamiliar for you, there are classes in JavaScript. If you want to use them, you can. They're great, like we've got classes in PHP, so you can. And we use alt here also to eliminate a lot of boilerplate. But for now, the only thing that's important is that we have a create to-do method, and that action gets dispatched. So it has a notion of alt, our dispatcher, and it will automate the dispatching through that process. What is on the other side of that action is a store that listens to it. So here, once again, we have alt, but we also import our to-do actions from our actions definition. And in our to-do store, we bind the actions to methods internally. And what we can do here is bind the to-do actions to create to-do method. And this is part of the boilerplate that gets removed, right? It will create a unique identifier for every method that you have there, so you have an easy reference in your stores. And once that is called, this method will be called. So in that handle method, we receive that payload, which is the to-do, and onto our to-dos array, we append the to-do. Then our application is the one that is actually going to consume it. And if we purely look at the presentational stuff, we need some kind of state, which has to-dos, and we can map over those to-dos, like we did in the batch list before, to create list items, which we then render in a to-do list. But, of course, this component does not magically know about the to-do store and not magically know how to listen to it. So you'll have to bind those listeners by using some callbacks, which are called in the application in the React component lifecycle. When a component will mount, you add your listener to the to-do store. When it's unmounted, you do your cleanup, so you unlisten. And whenever there's a change, we have this function that's called, and we receive the entire state of the store, and we pull that in internally. And when but this is only the methods for when your application is actually running. But when it's first loading, you want the initial state there, so you can get that directly from the store. But already, what you see here, we've got some things that are, well, they're not use problems, but we have our application, and we've got like a subcomponent in a way that's this to-do list. It's just a simple rendering thing. So what we could do is take that to-do list and the rendering of that and actually extract it out, refactor out a new component, which is a to-do list, and that's just basically the same, but then just a small portion of it. And we can reuse that in our application. So you can do like method abstractions that you might be used to in PHP, and then apply that same concept, but then for UI, which is really powerful, and it cleans up nicely. But then, of course, our application still doesn't do anything because we are not capturing our intent and we're not making sure that cycle is started. So what we can do is we can add a key down handler, and when when the enter key is pressed, we get the value of the text field, and we initiate the action. So we call the action, which starts the entire process. So this will actually take this action, go through the dispatcher, update the stores that we saw previously, and then update the application. So the view that's rendered here is going to be re-rendered, and then again be the single point of truth for our application output. That's nice, but what about my Laravel app? This is just in JavaScript itself. Everything here is running in memory. So I've created a small Lumen app. This is it. This is the entire app. It's just in the routes. It doesn't do anything. It's just a command that I need to store stuff. But you can get the notion. You get an HTTP request. You get the body, the JSON body decoded and to do. You store it, and then you return it. Pretty easy to do. And the powerful thing here is that we can actually go to our store and just, when we handle the creation of the to-do, we do a post request to the to-dos route with, as the body, the JSON content. When it's returned, that's in the then, we take the response and we append it to the to-dos array then, and emit the change. And this is actually already the entire lifecycle for your application, including the backend architecture. So you can create the entire app while running in memory, like easy for prototyping, and then hook it up to your application later on. So what do we know so far? We've got a way to describe our UI declaratively. Our UI can invoke actions which hold the intent, which get distributed through our system. We have stores that listen to those actions, call services, or update the internal state as is, and our UI will re-render. This is how we can apply the thought process of what we do in the backend in our front-end code. And it all has to do with how the data flows. We've got one cycle, we've got a unidirectional data flow, which is easy to follow, easy to debug, no change mitigation, and intent is everything. Complexity should be facilitated. React.js, in combination with Flux, is a tool that can do this for you. But wait, there's more. React can actually also run on the server. And this is a really powerful concept. You can take your views and render your backend application, like have the HTML being rendered on the screen. And React in the server and React in the front end are buddies. They have a way to tell the front end, like, I was rendered with React, so what you get here, I supply a checksum, the front end takes that checksum, checks it with the current application state, and if it's in the correct state, it will just do nothing. So instead of that JavaScript page build-up, your page is there instantly. And you can take the application state from the server into the browser and just keep going where the server left off. And this is a really powerful concept. This also means you have declarative UI across the board. And so what you could do is probably not one of Taylor's favorite things, but you could even remove Blade from the equation and just do React templates in the front and in the back all across the board. And that's really, really powerful. I hope by now you understand that you have the tools at your disposal to get this kind of workflow in order. It's super easy to get started with. I hope I removed some of the question marks that I had when I was first starting out in this. And thank you for your time.
Hello.
Hey.
Hey, Frank. My name's Kurt Wachel. I'm a representative of the Church of JavaScripters, and so we take some offense at some of your scathing attacks.
Yeah.
But two serious questions. First of all, that was awesome, and I think it's answered some questions I had for our application, which runs a very heavy PJAX layer. I'm just curious if you've used React in that sort of environment using a PJAX setup. And question number 2 is, are you ready to accept JS Christ as your Lord and Savior?
So I'll just address the first question then, the PJAX. I sometimes get why people use PJAX. It's like you return HTML straight off the bat, right? Mostly that's because templating is divided into 2 places. You want to be able to have like across the application, like be dry about your templates, not have two, like a back-end template and a front-end template, right? Or you have to invest in a templating language which could have its limitation. I actually think like it's a Band-Aid on a shotgun wound. It's like it's nice, but it's a patch. It's like it's not something that scales very nicely, because it's one of those workflows where you say, well, I don't like how I need to do it in JavaScript, so I'll just do it in the backend.
Yeah, I actually disagree a bit with that, because we originally used Angular.js for our application. A lot of us kind of jumped on the front end.
That's a first mistake, right?
Yeah. The full page app mistake, and we actually found over the long run that it became quite slow, particularly for complex pages.
Yeah.
Running 12, 13, 14, 15 seconds for the end user experience. So we ended up moving to PJAX in a way to actually speed up the process rather than any real dry approach. But we still need that front end complexity to be managed, and it looks like maybe React can help us do that. Yeah,
definitely, and also in terms of application speed in the client, what React. Okay, let's look at Angular first. Angular has the notion of state, which is basically one object that you have, like with the scope, right? In order to know what needs to be updated, or if there is a change anyway, JavaScript, like the JavaScript in Angular.js, will dirty check everything. This is a process that's very expensive, especially if you have mutating state. If you have immutable JavaScript, you remove a lot of this off the bat, because you can do a simple reference, is the old state the same as the new state? But within Angular.js, that type of workflows is not really facilitated very well. When you render React components, what actually happens is you are not rendering actual DOM elements, you're rendering a blueprint. And this blueprint is analyzed by React.js, the DOM engine. And so the first time it will create all the DOM elements for you. But the second time around, what it will do, it will take that last state it was in, the last blueprint, take the next one, see where it differs, and only perform actions to mutate the DOM into the next state, so you get full reuse of everything. It's even as smart as, like you saw the array map things, you supplied an index, so you know like what unique identifier that particular element has. It will even use that if you have a list of items and like something switched positions. It will know just to take that element from place 4, put it in place 1, which is incredibly fast. So a lot of the performance hits that you get in other types of things, but also with Mustache, because that's just strings, those are a thing of the past in React.js, which is awesome. So, any other questions?
You can just stick up your hand and we'll come to you. Here you go.
Thanks. So we saw that you used HTML inside of your JavaScript. What's your take on CSS as inline?
Oui. Yeah. So everything is a transition. This is like, I do not like that per se, not because of the separation of concerns or anything, but more how I think about in developer workflows. We're like working in teams. A lot of is still like we have some people that do the designs, and what I expect from designers to get back is also the HTML, like the hierarchy, and then I use that in my templates. And so for me, it doesn't fit into my in my workflow. But if you have highly complex widget-like systems, that's actually something that really scales very well, because everything is even more independent. It doesn't even have a notion of a global styling. So it's one step beyond. It's like with JavaScript solutions, only use it if it's applicable for your case. I'm totally fine with seeing CSS in JavaScript, but it wouldn't be my go-to method of doing it. Does that explain what? It's really not an explanation, but yeah.
That's a good question. Does anybody else have any questions or just anything that they want to say politically about JavaScript?
You mentioned in your talk rendering React server-side, but you're talking JavaScript server-side. I'm not talking PHP here, correct?
JavaScript, yeah.
So you still don't really have a bridge with your Laravel application. You don't really have. You still have to talk to a JavaScript server from your PHP application, which then talks to your front end. There's like 3-step now instead of 2. You have to.
True. But it's such an easy point of delivery, though. You have your data, your node application, which you'll have to have in cases like this. You can do V8 bindings, but they're a pain. I've been through that process before. You basically want to cry in a corner for the entire time that you're doing it. But PHP is a language that talks really well over HTTP, and coincidentally, so is JavaScript. So if you use HTTP as the middleman, you can just have an app that's like your database is externally, and you talk over some kind of networking protocol, in this case HTTP. It's an easy separation. And an added benefit for that, if you do it over HTTP, it's also fault tolerant. Because if your Node app crashes for what reason whatsoever, and you catch that exception and just leave the output blank, the front end can just pick up and see, well, I didn't get a response, let me render everything for you. So it has many more benefits.
Okay.
Hi Frank, how are you?
Where?
Top.
Oh, there you go. Oh, hi, Scott.
Hi Frank. 2 things. Are you going to move to JavaScript full-time anytime soon? Ditch PHP? Or
No.
PHP?
I really love doing PHP. I do JavaScript mainly as in front-end situations like this, so I don't see me making the move to JavaScript. But if you see a JavaScript or a Flysystem.js, then you might realize I have lied and I've left you guys. No, but no, that's not going to happen.
One other thing, happy birthday for Friday as well.
Thank you, Scott.
Okay, is that the end of the questions? Anybody have anything else? Oh, here we go.
Hi, my name is Bajiros. You kind of just got asked that before, but where do you see PHP now fitting in this complicated picture that we're getting with server-side Java stuff, with embassies in the browser, and then your PHP on the other side? I mean, why would you carry on using PHP, actually?
Sorry, the sound is kind of muffled. I couldn't really...
I was just saying, sorry, it's the distance. I just don't see where you can see PHP in that emerging picture in, let's say, 5 years' time, if we move more and more of the UI logic on a server-side Java thing. What do you leave for PHP?
I leave my domain handling for PHP. I don't do any database interaction. I don't do any business intelligence there. Those are the things like we do in PHP ourselves now. And if you look at purely the view, how many of the people out here have actually created a templating engine? Well, I know one. But for the majority cases, that's not your domain. So the domain aspect of handling the application intent, that's still there. So that doesn't necessarily have to move.
And perhaps pass that over an API, for example.
Sorry, what?
And perhaps just have your PHP to speed things out now.
Yeah,
an
yeah,
API. And then
yeah, you could even, instead of having PHP being the front-facing thing, you could have a node application being the point of delivery, and it just makes calls to your your core API service that you write in PHP. It's a perfectly legit way of doing it. Yeah.
Okay, I think that's all the time we have for questions. Thank you very much, Frank.
Thank you.